Okay, so today we're going to find inverses of our exponential and logarithmic functions. So, an exponential function is an equation in the form y equals b to the x. So the x is in the exponent. Okay, it can't be anywhere else, it has to be in the exponent. Where b is the base, such that b has to be greater than 0. So we talked about this a little bit. B cannot be 0, and it has to be positive. And then b cannot equal 1. So for example, 2 to the x, or 3 to the x, or 7 to the x, or 1/2 to the x, anything like that. Okay, so if we want to find the inverse function, so inverse function, if I have an exponential, then the inverse is, oops, sorry, I was going to write inverse. The inverse is a logarithmic. And then vice versa. If I have a logarithmic, my inverse is an exponential. Okay, so the first thing we're going to do is replace that f of x with y. So this over here I'm going to rewrite as y equals 2 to the x power. Okay, we're going to switch x and y. So we've done this before, finding the inverse. It's just now it's going to be a little bit different mathematical steps to get to your inverse. Okay, so let's switch x and y. So now x equals 2 to the y power. And we want to solve for y. All right, so I have an exponential equation here. So we did this a little bit yesterday, although instead of starting like this, I'm going to rewrite this as 2 to the y equals x. Because this is how I looked at it yesterday, where we had our exponent, our base and our exponent on the left, and what it equals on the right. So I'm going to say log base 2, because this is the 2, of x equals y. So the base comes from here, the power is on the right-hand side, and then what it equals is on this side. Now I already have y by itself, by just that simple step. And then we want to replace y with f inverse of x. So our inverse function of 2 to the x is log base 2 of x. So those are inverses of each other. So this is just what I was saying earlier. The inverse of an exponential function is known as a logarithmic function. Okay, so some properties that we have of logarithms and exponents. These are just some special properties that work every single time. So this first one, if the base here is the same as this, then whatever this little power is going to that's what your whole thing equals. So for example, number 1, you have the base is 3, and then this is also 3. This whole thing will equal 11. So we had one like that on our notes yesterday, and I had you guys go ahead and write it out. 3 to the x power equals 3 to the 11th, and we can see x equals 11. But you can use this property and just say, oh, well, I know that if it's log base 3 of 3 to the 11th, the whole thing just equals 11. So I could rewrite this one in that same kind of form. I know that 27 is 3 to the 3rd power. So because this base and this base are the same, this whole thing equals 3. Same as number 3. So the bases are the same. This 8 and this 8 are the same. This whole thing just equals 3x minus 1. Okay, our second property is if you have an exponent, a base being raised to an exponent with a log in it, and the base of the log is the same, it equals whatever this value is. So an example, it's hard to see this, but an example would be like number 4. So this, if I rewrite it so you guys can see it, it's a 2, and the power is log base 2 of 27. So if the base of the exponent is the same as the base in the exponent, then the whole thing just equals 27. Number 5, remember, there's no base written here, so ask yourself, okay, so what is the base? We talked about today, it would be a base of 10. So these two are the same. This just equals 0.9. Number 6, I'm going to rewrite this. I know that 5 to the third is 125. So now I have these 5s the same. So this whole thing just equals 6. Number 7, the 5s are the same. So this whole thing equals 10. And number 8, let's set this one equal to x. 6 to what power equals 1? So x would equal 0. That's that tricky one. So those are just some simple properties that can help you do some of the ones a little bit quicker. Okay, so now on the back, we're actually going to find some of the inverses. So first thing, let's rewrite this as y equals log base 4 of x, and let's switch x and y. So x equals log base 4 of y. Okay, now we're used to seeing this switched. Like yesterday when we did this, we had this whole thing on the left-hand side. So I'm going to actually rewrite this. Log base 4 of y equals x. Okay, so we are solving for y. So how do I get rid of a log? I put it in an exponential equation. So I take 4 and I do 4 to the x equals y. And I just solved for y. So when you look at this log, you're like, what the heck? How in the world am I going to get y by itself? You do the inverse of it, and that's going to get that y by itself. So then, of course, we'll write our answer as f inverse of x equals 4 to the x power. Okay, number 2. First thing, let's change this to a y. Let's switch x and y. Now I'm going to rewrite this because, again, just like here, from here to here, I just switched the sides. I'm going to do the same thing on this one. So from here to here, I'm just going to go 3y minus 4 on the left equals x on the right. Now on this one, I cannot do a log until I have this by itself. So I'm going to add the 4 over. So 3 to the y equals x plus 4. Now we're going to put this in logarithmic form. So let's just review that really quickly. If I have 2 to the third equals 8, I write that as log base 2 of the value 8 equals the power 3. So the same thing here. Log, the base is 3, of the value x plus 4 equals the power, which is y. Okay, so this takes a little time getting used to. So make sure that when you're writing it correctly. So this is why you have to learn this, so that then when we get to finding inverses and solving equations, you know how to put it in the proper order. So we say f inverse of x equals log base 3 of x plus 4. Okay, number 3. Let's go ahead and change this to a y. Then let's switch x and y. Now again, from here to here, I'm just going to switch the right and the left side. So I'm going to say log of x plus 2, log of y plus 2 equals x. So how do you undo a log? You put it in exponential form. So our base here, we start here, there's nothing written, so it's a 10. So 10 to the x power equals y plus 2. Now I want to solve for y. The y is not by itself yet. I have to subtract the 2 over. So now I get y equals 10x minus 2. So our inverse function, and make sure that I can read this, 10 to the x power and then minus 2. So the minus 2 is not up in the power. Make sure that you distinguish between where you're writing that. Okay, number 4. First thing, let's rewrite that with a y. So we have y equals log base 5 of x minus 1 all over 4. Let's switch x and y. So x equals log base 5 of y minus 1 over 4. Okay, so we want to get the y by itself. Let's do a little just basic algebra here. This 4 is being divided, so let's go ahead and multiply it over. So it goes away here, so I get 4x equals log base 5 of y minus 1. Now again, I don't like that the log is on the right, so I'm going to reverse the order. I'm going to go up here. So I'm going to rewrite this as log base 5 of y minus 1 equals 4. Okay, so I have a log. How do I undo a log? I put it in exponential form. So I start here. I lost my x somewhere. There it is, 4x. So I say 5 to the 4x power equals y minus 1. Again, we want to solve for y, so I'm going to add the 1 over. So y equals 5 to the 4x plus 1. We can write that as f inverse of x equals 5 to the 4x power plus 1. And I know it looks weird and it's hard to check your answers here. So you just need to take it nice and slow, make sure that you find the inverse correctly. Okay, number 5. Let's change that to a y. And let's switch x and y. So x equals 6 times 3y plus 7 minus 2. So I have an exponential. I'm going to go to a log. What I need to do first, though, is get that exponential part by itself. So I'm going to add the 2 over. So I get x plus 2 equals 6 raised to the 3y plus 7. Okay, now again, I'm going to switch the left and the right side. So 6 raised to the 3y plus 7 equals x plus 2. Now I'm going to put it in logarithmic form. So log base 6 of the value x plus 2 equals 3y plus 7. Now don't forget here, you're solving for y. So this is just your basic algebra. Subtract the 7. And notice I don't combine the 7 with anything. So this log thing that I have here, this, I cannot separate this now. So I'm just going to subtract 7 from that, and it equals 3y. So then, how do I solve for y? I divide by 3. So let me come back up here. So I have y equals log base 6 of x plus 2 minus 7 divided by 3. And now it looks weird and crazy, but that's it. So we'll rewrite that as f inverse of x. Sorry, I'm running out of room. Oops, that's a 3. And that's it. Okay, and the last one, number 6. Which statement describes the function, how the function f of x equals 2 times 3 to the x is related to its inverse? Okay, so this is an exponential function because I have this exponent here. So the inverse has to be, inverse must be a log. So the inverse function will be exponential. No. The inverse function will be exponential. No. The inverse function will be log, possibly. The inverse function will be log. So we need to look at which one's going to have the 2 or the 3 as the base. Well, up here, if this 3 is the base, that means in our log, 3 also has to be the base. So D.